and make it level. Okay, so with 8A, we're just going to talk through this question, very basic maths, some stuff you might do sort of year 8, year 9. So we're going to talk through 8A, pick one to do from the textbook, and then move on to 8B. So, hope you all had a wonderful holiday, by the way, welcome back. All right, so 8A, let's have a readable. We've got continuous random variable. Okay, let's really emphasize this point. Remember, in chapter 7, we did discrete random variables. Those are things that you count. Now in chapter 8 and most of chapter 9, we're talking about things that you measure. So that means they occur over an interval. And so we've got 50 eggs are weighed at random, and their weights are shown in the frequency table below. So this is continuous data because you're weighing them, you're measuring their weight, right? And so we have 6 eggs between 50 and 55 grams, okay? So the relative frequency, you can see 6 eggs out of 50, 0.12, and the table goes on to show it. We could also represent that data as a histogram, right? And that's what they've done here. Okay. The probability of so this is just a point to make. The probability of a continuous random variable being equal to an exact value is always 0. For instance, if the continuous random variable x is the weight of an egg, then the probability of finding an egg whose weight is 62.9 is 0. And the reason is because no egg weighs exactly 62.9. If you keep measuring and you have finer and finer gradations of measurement, there's always going to be some small amount of variability. And that's the thing about when you have an interval, is that you can always keep dividing. You can always get smaller and smaller. So they never meet an exact value, they always occur over an interval. So then we have this question here. Find the probability that a randomly selected egg weighs between 55 and 65 grams. Okay, so based off our evidence here, we're going to look from 55 to 60, that's a probability of 0.26, and from 60 to 65, that's a probability of 0.4. So therefore, the probability that an egg weighs between 55 and 60 is going to be 0.26 plus 0.4, 0.66. Okay, based off the evidence that we have here. All right, so that's it for 8A. They're introducing you to that idea of sort of relative frequency and performing probability calculations based on that. Notice how all probabilities add up to 1. Anything else to say? No. Okay, so that's 8A. So from exercise 8A, Hayden, you guys will choose one question, have a go at that one question. What we're really developing though is some knowledge in exercise 8B. So the example I've got is going to explain 8B1, 8B2. I think today we'll just work through 8B1 and spend some time on the folio following that. So what we're talking about is what we call a probability density function, okay? So we can use a function to describe the probability of a particular event occurring. So we've got for a continuous random variable x, from the interval a to b, the probability density function is the area under the curve. Okay, so the probability of some event occurring from C to D is going to be the area under the curve from C to D. Right down the bottom, 2 points that make a probability density function valid. Okay, there's 2 things we need to consider. The first is that the area over the interval is 1. Has to be, because all probable events add to 1. Can't exceed 1, can't be less than 1, has to be 1. And then the second one, sorry, that's the second point. The first one is that the function has to be positive, because you cannot have negative probabilities. Okay, so they're pretty straightforward points that we're familiar with. All right, we've got a table summarizing how to calculate the mean, median, mode, and different properties of the probability density function. Let's get straight into the example. So we have the function x on top of a, and we're told it's valid over the interval 0 to 4. Okay? The function x on top of a is valid over the interval 0 to 4. Find a given it's a valid probability density function. Well, given that it's valid, it means the area under the curve from 0 to 4 of this function is equal to 1. Okay, the area under the curve has to be 1, my dx there. And so we're just going to solve this integral statement for a. So if I was solving this, what I do, a is a number, right? And I'm going to pull it out the front. We're going to have 1 on a out the front. Integral from 0 to 4 of x. Alright, and then I might even multiply both sides by a, so that I've got integral from 0 to 4 of x with regards to x is equal to a. Like I've just already solved it for a, I just need to process this integral. That's something we can do in our calculator, it's something we can do using the fundamental theorem of calculus, doesn't matter. I'll go through here just to refresh us. Hopefully we've been doing the folio, which means it's pretty fresh in our mind anyway. But this will be x squared on 2 from 0 to 4. We've got 16 on 2, take 0 on 2. We've got 8. A is 8. Okay, so that's part A. All right, let's move on to part B. Find the mean, median, and mode. All right, so let's do the mean first, and we're referring to the table up above. All right, so the mean, it says, is the integral from a to b of x f of x. Okay, so in our circumstance, that means the integral from 0 to 4 of x times, what's the function? X on a. The function is x on a, and the value of a is 8. And so we're just evaluating that integral. This time we will use our calculator. All right, and we'll use it for a couple of the other ones too. So option calc integral, so it's x squared on 8 from 0 to 4. We're going to have 8 on 3. So the average result on this probability density function is 8 on 3. Part C, find the median. Okay, so we've done the mean, let's do the median. Okay, now the median is m, such that the integral from 0 to m of the function, x on 8, is equal to half. All right, so the median is m such that half of the probabilities are to the left of m and half of the probabilities are to the right of m. So we can go through and solve this using integration, or if you want to solve this on your calculator, you can put this into equation solver. Okay, this one we'll do manually. So we're going to have x squared on 16 from 0 to m is half. And then sub in m, we're going to have m squared on 16 is half. 0 is just, when we sub in 0, it just goes to 0, so we don't need to consider that part. Multiply both sides by 16, m squared is 8, square root. And we don't consider the negative value because the domain is between 0 and 4. So square root of 8 lies between 0 and 4. Median, okay. And then the last one is the mode. And the mode just says it's the x value that corresponds with the highest y value. Okay, it's the event that corresponds with the highest probability. So this is where it's helpful to have a graph of it, and I'm going to sketch this function. The function is x on 8, right? Or we can think of it, you can even think of it like this, 1 on 8 times x. It's the equation of a line, has a y-intercept of 0, and a slope of 1 on 8. So if you sketch it, this is what it looks like. It has positive slope, it's going up. Okay, it's valid between 0 and 4. All right, and along the y-axis, all right, we have the probabilities, right? The probabilities considering their relative position with regards to x. Okay, so what is the x value with the highest probability? Over this interval, 4. The probability is highest here, so our mode is 4. Alright, the x value that corresponds with the highest probability is 4. Our median we saw was square root of 8. Alright, so that's like here somewhere. And what that means is half of the probabilities are on this side and half of the probabilities are on this side, right? The integral from 0 to the square root of 8, that's going to give us a value of half. Interval from the square root of 8 to 4, that's going to give us a value of half. And then we had the mean was 8 on 3. Very good. So that's the mean, median, and mode. Next, we've got variance and standard deviation. So we've got two formulas there to match those. So I might just type in variance and standard deviation here. So we'll do variance first, and then for standard deviation, we'll just square root it. And we can use either of those formulas. So I reckon, let's go with the second one. Looks like there's a bit less typing to do. So we've got, I'll write the formula and then I'll sub in the points. We've got x, take the mean squared, times the function with regards to x. So in our circumstance, that's going to be the integral from 0 to 4 of x, take 8 on 3 squared. All right, we've calculated our mean, it was 8 on 3. Multiplied by the function, which is x on 8. And then integrating with regards to x. So that's a nice easy one, chuck in your calculator. That's going to be the variance for us. So x, take 8 on 3 squared multiplied by x on 8 from 0 to 4. 8 on 9. So that's the variance, right? And so then the standard deviation is the square root of that. And you can simplify that, root 8 on top of 3. So that's part C. And then lastly, part D. So I might rub out our initial calculation here. Part D. Now, it's a probability density function. And we're asked, what's the probability of events between 1 and 2? It wants to know the probability of the event between 1 and 2, and that's going to be the integral from 1 to 2 of our function. Okay, so yeah, smash it in your calculator, do it manually. On 16, from 1 to 2, we're going to have 4 on 16, take 1 on 16, 3 on 16. All right. So yeah, that's probability density functions. They do follow on a fair bit from probability distributions that we've been doing. You can see they're the same properties, right? Probabilities have to be positive, all probabilities add to 1, but now we're integrating those integration techniques. One other thing to say, when we're talking about continuous random variables, there is no significant difference between less than or equal to and less than. All right, so when you're asked to perform a probability calculation, these mean the same thing, okay? It's when we're talking about discrete values that they're different, that there's a significant difference, right? Reason being, for those of you that have done spec maths, this is a bit of a side note, something I can show you that's quite interesting. Is it true that 9.999 recurring equals 10? True or false? True. False. True or false? A couple of people have said it's true, a couple of people have said it's false. It's actually true. Do you guys want to see why? Yeah. It's quite interesting as to why. It's quite a good argument, it's a valid argument. So here's what we'll do. We'll do something like this. We'll go let x equal 9.9 recurring. Okay? Therefore, 10x equals, what would 10x be? 99.9 recurring. Alright? Then I've got both sides of this equation. I'm going to subtract x from both sides of this equation. So I'm going to have 10x take x equals 99.9 recurring, take x. So over here, this is going to simplify to 9x. And over here, this is going to be 99.9 recurring, take away 9.9 recurring. What does that simplify to? 90. 9x equals 90, x equals 10. Cool, eh? So, yeah, so because these are equal, there's no significant difference between that and that when we're talking about continuous intervals. So, yeah, excellent. All right, so one question from 8A, and then we'll leap in.